Alright, let's dive straight into the fascinating world of solar sails and how they make use of solar radiation for propulsion. Imagine a ship sailing across the ocean, powered by the wind that billows its sails. Now, picture that same concept, but in the vastness of space. That's essentially the idea behind solar sails. Instead of wind, these sails harness the power of photons, the fundamental particles of light, to propel a spacecraft. Consistent, and you might be thinking, wait a minute, light doesn't have mass, so how can it push anything? And photons may not have mass, but they do carry momentum. When a photon strikes the reflective surface of a solar sail, it imparts a small push. This is known as radiation pressure. Now, this push is incredibly tiny, but when you have a constant stream of photons from the sun hitting the sail, all these little pushes add up, and over time it can accelerate a spacecraft to incredibly high speeds. The great thing about this is that the fuel, in this case sunlight, is abundant in space, and it's completely free. So a spacecraft equipped with a solar sail can keep accelerating as long as it's exposed to sunlight, without needing to carry any fuel on board. Solar sails are also incredibly lightweight, and they can be folded up for launch, which makes them a very attractive option for space exploration. But as with any technology, there are limitations and challenges as well, which we'll explore next. Moving on to our next line of discussion, let's delve into the potential role of solar sails in enabling interstellar travel and how they stack up against traditional propulsion methods. One of the biggest challenges in space travel is the sheer distances involved. Even traveling to our nearest stellar neighbor, Proxima Centauri, at the speed of our fastest spacecraft, would take tens of thousands of years. Traditional rocket propulsion simply isn't feasible for such journeys. This is where solar sails could potentially revolutionize space exploration. The key advantage of solar sails is that they provide continuous acceleration. While the force from each individual photon is tiny, the cumulative effect over time can be enormous. With enough time, solar sails could propel a spacecraft to a significant fraction of the speed of light, making interstellar travel a real possibility. A solar-sailed spacecraft doesn't need to carry fuel, which means it could be much lighter and thus easier to accelerate. Plus, as long as it's in the sunlight, it will keep accelerating, allowing it to achieve speeds that simply aren't possible with conventional rockets. It's like having an infinite fuel tank that never runs out. Moreover, because solar sails use the sun's energy, they're a much more environmentally friendly option for space travel. No burning of fossil fuels, no nuclear reactors, just good old sunlight. That being said, it's not all smooth sailing. Solar sails also have their limitations, especially when we start considering travel within our own planet's atmosphere, but we'll dive into that in a bit. For now, let's take a moment to appreciate the potential of this technology to take us to the stars. Alright, now that we've discussed the possibilities of solar sails, it's time to look at the flip side of the coin. As promising as this technology is, it does come with its own set of limitations and challenges, especially when we consider terrestrial flight. First off, solar sails rely on sunlight for propulsion, which means they work best when they're close to the sun. The further out you go, the less sunlight there is, and hence less propulsion. This makes them less effective for deep space missions, unless we find a way to overcome this limitation. Next, let's talk about terrestrial flight. The concept of solar sails becomes rather impractical within our planet's atmosphere. You see, the force exerted by sunlight is incredibly weak compared to the forces we deal with on a daily basis here on Earth, like gravity and air resistance. Just to put it into perspective, the pressure exerted by sunlight at Earth's distance from the sun is about 9 micronewtons per square meter. That's about the weight of a paperclip spread over an area the size of a football field. So, you can imagine how a solar sail would struggle to overcome even the slightest breeze on Earth. Another challenge is the size. To gain any significant propulsion, solar sails need to be large. We're talking square kilometers of surface area. This poses engineering challenges in terms of manufacturing, launching, and deploying such large structures in space. Also, solar sails are quite delicate. They need to be thin and lightweight to be effective, which makes them vulnerable to damage from micrometeoroids and space debris. But don't let these challenges dampen your spirits. Remember, every new technology comes with its own set of hurdles, and overcoming these hurdles often leads to new and exciting breakthroughs. Speaking of which, let's move on to our next topic and discuss the current research and advancements in the field of solar sails. Now let's shift our focus towards the current research and technological advancements in the field of solar sails. While the concept of solar sailing has been around for more than a century, it's only recently that we've begun to see it put into practice. In 2010, the Japan Aerospace Exploration Agency, JAXA, launched IKAROS, the first spacecraft to demonstrate solar sail propulsion in interplanetary space. Since then, we've seen other successful demonstrations, like the Planetary Society's LightSail 2 mission in 2019. Today, researchers are exploring ways to make solar sails more efficient and practical. One area of focus is the design and material of the sails. They're experimenting with different types of thin, lightweight, and highly reflective materials to maximize the sail's responsiveness to solar radiation. Another exciting development is the concept of laser-propelled solar sails. This involves shooting a high-powered laser at the sail from a station on Earth or in space to give the spacecraft a significant speed boost. Theoretically, this could propel a small spacecraft to a significant fraction of the speed of light, making interstellar travel feasible within a human lifetime. There's also ongoing research on deployment mechanisms for the sails. Given the size of these sails, deploying them in space without causing damage is a significant challenge. Engineers are developing innovative techniques to safely unfurl the sails once the spacecraft is in orbit. Looking into the future, solar sails could play a crucial role in a variety of missions, from exploring our solar system to monitoring space weather, and perhaps even taking us to the stars. However, there's still a lot of work to be done before solar sails become a mainstream propulsion method. But with the progress we're seeing, that future might not be as far off as we think. Now, let's take a step back and look at the history of solar sails. All right, let's now delve into the fascinating history of solar sails and the significant milestones in their development and implementation. The concept of solar sailing actually dates back to the early 17th century when Johannes Kepler, the famous astronomer, noticed that comet tails always point away from the sun. He speculated that some kind of solar breeze was responsible, and he even suggested that vessels might one day sail through space using giant sails. Little did he know how right he was. Fast forward to the 20th century. The concept is further developed by scientists like Carl Sagan, who championed the idea of solar sailing as a means of interstellar travel. However, it wasn't until the dawn of the 21st century that we saw the first practical attempts to implement this technology. In 2010, the Japan Aerospace Exploration Agency successfully launched IKAROS, the first spacecraft to demonstrate solar sail propulsion in interplanetary space. This was a massive milestone and proved that the concept was viable. Then, in 2019, the Planetary Society's LightSail 2 mission took things a step further. This crowd-funded spacecraft not only successfully deployed its solar sail in Earth's orbit, but also demonstrated controlled solar sailing for the first time. These missions have paved the way for future solar sail-powered spacecraft. For example, NASA's upcoming Near-Earth Asteroid Scout mission we'll use a solar sail to visit one near-Earth asteroid. Looking back, it's fascinating to see how far we've come from Kepler's early observations of comet tails to the cutting-edge research and technological advancements of today. It serves as a testament to human ingenuity and our relentless quest to explore the cosmos. And who knows where solar sails might take us in the future? Maybe to the stars and beyond.